Okay, so I'm just going to quickly sketch out what we just found by plotting some points in there. And that is f of x equals 1 over x has this kind of shape to it, okay? So the axes kind of set up boundaries for where the little curvy pieces have to go, okay? So, and that type of graph that we just did there has a special name to it, too. It's called a hyperbola. And we'll study hyperbolas a little more at the end of class in this trimester. Okay, so think transformations. So if this is what 1 over x looks like, this is the parent function, this is kind of the home base. Let's say I want to do g of x equals 1 over x plus 2. What kind of transformation am I doing to the original graph? Up 2, right? Okay, so if I'm going to move this graph up 2, what's that going to look like then? So what do you guys think? How would I draw that? What do you think would be a good thing to start with if I'm going to move it up? Use those asymptotes as kind of a guide. Do you see how the two asymptotes kind of make a little cross? Right? Right now it's the two axes, right? But that little cross is going to move up, down, left, right with the graph depending on how I choose to move it. Okay? So if I'm going up 2, I'm going to take that cross, those two asymptotes that cross each other, and move that up 2. Okay? So for this one then, and we always use dotted lines for asymptotes. So this horizontal asymptote now is going to be up at 2. Okay? And then the little curvy pieces fit into that. Okay? The y-axis, I haven't moved that left or right. That stays right where it's at. Okay? So that vertical asymptote is still right there. So this little piece right here is going to be here. And this little piece down over here is going to be like that. Okay, does that make sense? Just use the asymptotes as a guide and move those, and then just, they have to, like I said, those are kind of like a little boundary they have to, everything has to fit into. So you can do it that way. All right, let's do another one. How about, all right, so what's going to be happening with this one then? If I have 1 over x minus 3 minus 2, there you go, good. I'm going to focus this in a little bit better too here. There we go, better. Okay, somebody said it, what is it? Right. Uh-huh. Good, yeah, right 3 down 2. Okay, so let's try that. So that vertical asymptote, since we're going to the right 3, should now be over at 3. And the horizontal asymptote went down 2. Okay, so do you see how I kind of took the two, that cross, that was the two axes, and it moved it down over here? Okay, so now the two little curvy pieces, here and here, are going to go here and there, right? It's just going to move right with it, right with those asymptotes, and it gets caught inside of those. So we got one piece that does something like this, and that other piece should be something kind of like this. It's important when you graph these, though. Notice how I'm putting the little numbers here, where these asymptotes are crossing. You got to have that, though. If you don't have that, put those on there. Because that shows, by labeling those asymptotes where they're at, that shows where that translation happened from where to where. Okay? So that's how we can do some quick translating with that hyperbola, that original rational function. Other types of transformations that you guys have done, we've done some reflections over axes as well, right? So you can, but it's hard to see. So we will talk a little bit about that, but I'm gonna avoid that for right now. But we will in a little bit kind of talk about what those would look like. You doing your count? All right.
Do you know what tomorrow is for the dress-up day?
I don't know. Shouldn't you know that? Red and green tomorrow, guys. Red and green. Yep. Okay, here we go. How about this one? Hello. Okay, so 1 over negative x. So I've replaced x with negative x. And so we're going to take this thing and make it a reflection over the y-axis. So I'll write that down. So I'm going to reflect this over the y-axis. So then that piece that used to be over here in the first quadrant, where's that going to be now? Nope. Second quadrant. One, two, three, four. 1, 2, 3, 4. Yeah, it goes this way. 1, 2, 3, 4. All right. So, anywho, the part that's normally right here in the first quadrant gets reflected over into the second. And then there was this piece over here that's also going to get reflected over the y-axis into the fourth quadrant. So it's going to look like that. And so there is our reciprocal function, but reflected over that y-axis. Yeah, I was just about to do that one with you. See what you notice. So let's do it one more time. What if I just had negative 1 over x? If you put a negative in front of the entire function, what is that? Reflect over the x-axis. Okay. So if I'm going to reflect this thing over the x-axis, this piece that's in the first quadrant would get reflected down into the fourth, so it would look like this. And then the piece that was down in the third quadrant right here, it would get reflected up into the second. What do you notice?
Please excuse the interruption. We have a few announcements. The winners for the winter wear.
Why are they the same? How are these two giving me the same thing? Okay, I got like 5 different answers. Somebody raise their hand. Okay, Abby. They do. Yeah. Yeah, you end up ultimately with the same answer when you plug numbers in for x, right? The negative, when you have a fraction, does it matter if the negative's in front of the whole fraction or just on one little piece of the fraction? No, you get the same thing. You plug the number in, you make it negative, you're going to get the same thing. So with this particular function, doesn't work with all of them, right? But with this particular one, doing a reflection over the y-axis or x-axis, it's all the same. Doesn't matter, okay? So you could just write a reflection over an axis and it's, yeah, yep. Okay. Let me do one more here, JK. We're up to L of x. I'm going to put a translation and a reflection together on this one. So we'll go negative 1 over x plus 2. Mm-hmm. Yep. So it's to the left 2, but then also reflected over the x-axis. All right, so that vertical asymptote is going to come over to negative 2 now. All right, so if there was no reflection, okay, if there was no reflection, it would be like this and like that, right? But I got to reflect that over the x-axis. So this is going to look like this and this. All right, was everybody able to follow that? Okay. So what I'd like you to do, we're going to practice this a little bit on your own. I'd like you to open up your journals for me, please. Let's go to page... we should be good there. Yeah. So we're going to go to page 190. Oh, 198. Okay, here's what I'd like you to do, though. Because we haven't gotten into any stretch and shrinks yet, and I don't want to get into those today. So I'm going to modify some of these questions just for now, so we don't have to worry about doing any of that. So, number 1, here's how I'd like the question. Take that 0.25, make it a 1, and then I'd like you to do plus 1 on the end of it. This one, just make that negative 2 a negative 1. And then number 4, because number 3 is fine. Number 4, make this negative 3 a negative 1. Okay, so then I'd like you to do 1, 2, 3, and 4. Okay, so over here, number 1 is going to be 1 over x plus 1. Number 2, just negative 1 over x. Number 3, it's fine. And then number 4, negative 1 over x minus 4. All right, see what you can come up with. I'll do the same thing. All right, now you can hear me. So again, for those listening at home, we're going to divide these and then use synthetic division to divide them and then see what we got, and then use that to graph. Okay? So x plus 3 divided by x plus 2. Now the way I learned synthetic division, I don't know if Mrs. Court did this differently or not, but the way your book does it, they make like a big L like this. Did you guys do it that way?
Oh, yeah. I don't remember. I don't remember. Did you guys not have it? No, I didn't, but I just don't remember.
Okay, well,
I'm going to do it. I'll show you how it works if you're confused. But I'm going to do it like the book did it then, since you guys have done it that way. So this x plus 2, the one you're dividing by, you always take what makes this 0, and that goes up here. That's your k. So negative 2 in this case. Okay. And then we take the all the numbers from this one and then just write them across. Okay. I'm trying to remember exactly how this looks now, because this is still different from what I'm used to. So they did that. Oh, where was that? Sorry, I just want to make sure that I'm doing it exactly the same way, because I've never seen it done this way before. Sorry. 173. Yeah. All right, here we go. All right, so I just made this a little bit too big. It goes like this. All right, and then the coefficients off of this first one go here, 1 and 3. Okay, so the first step is always you bring the first one down, and then you multiply. Negative 2 times 1, and it goes under here. Negative 2, and then you add these up. 1. Okay, and then this number right here was always the remainder, right? Okay, so to write out the result of this division that you did, it's going to be 1 plus, okay, so it's the answer, 1 plus the remainder divided by x plus 2. So it would look like that. Okay, now if you prefer long division, it would look like this. So then you ask yourself, okay, what do I need to multiply x by to get x? 1. 1 times x, x. Oh, the 1 should go here, sorry. And then 1 times 2, 2, so x plus 2. But then I got to subtract in this way. Those subtract, 3 minus 2 is 1. And then it's the same thing. This is your remainder on that one. So 1 plus 1 over x plus 2. So it just kind of depends on which way you'd rather do it. But the goal is to get it to look like this. Because now, do you see how that's in a form that we can graph it, like we were looking at yesterday? I can tell what the vertical translation is. I can tell what the horizontal translation is. And I can actually go after that one and do it. Question?
Have you ever used lattice before?
I have not personally, but I know how to do it. I do not like lattice at all. That's your synthetic division? Anyway, all right. So this one, if I'm going to graph this, okay, where is the, let's start with the vertical asymptote for this one. Vertical asymptote. Left 2. Okay, so we're at negative 2. Okay, and what is the horizontal asymptote? That's the one that's up 1. Yep. Okay, so any reflections at all in this thing? Nope, there's no negatives in there, so there's no reflections. So it's going to be the same shape as a reciprocal. So it'll be caught in here and here. So this graph here represents this original one as well, right? Because when we divided it, we just wrote it in a new way and then did what we did before to make what the graph looks like. All right? So I'm going to give you guys a little bit of practice with this.
Yes.
Oh, yeah. Bad. Sorry. It'd be like that. Sorry for all of you working in pen. My bad. But yeah, that should have been scooted over. And this is actually going down, not up. I'm kind of sick, sorry. My brain's not really with it. Okay, I'm going to give you guys a few of these to try. I would like you to sketch graphs of each of these. Doing what we just did there, same type of a thing. So try that one, and then we'll do x plus 2 over x plus 10. All right. Give it a try. When you're done, like I said yesterday, with these, the graphs don't have to be like spectacular. Just as long as the asymptotes are labeled in the correct place, then that's fine. Okay? And I don't care if you want to do synthetic or long division. Makes no difference to me. Whatever's easier for you.
How do you graph it without a calculator? Like,
This is the vertical asymptote, right? The x plus 1 means that we got moved to the left 1.
yeah.
And then this 1 out here, think of that as like a plus 1 on the end. It means it got moved up 1. So,
And we're starting from 0 then?
yep.
Okay. Thank you.
Mm-hmm. All right, so we can double check really quick just to make sure you got the synthetic division or regular division done correctly. I'm just going to put it, well, I guess I can show you everything I got here. Double check these. See if you got the same result as me if you divide it. Yeah? Nope, see how I have that right here? And then I just rewrote it down there. The only reason that I rewrote that thing is just so it looks like the ones we did yesterday. It's like everything's in the same spot, but algebraically it's exactly the same thing. And if you can follow that first one and know how it's supposed to move, then that's okay. That's fine. I just think it's easier to think of them like this because we're used to that. But all right, so the first one, let's see if we can figure out what this thing looks like. All right, so it moved, you've got an asymptote at -1, and then another one at +1. Okay, so this is at -1 over here. Okay, and then we've got another asymptote at, the horizontal is at +1, right? But it's a -8, so it means it had a reflection over the x-axis, right?
Yeah,
So that reflection over the x-axis, well, normally it would look like this and this, so now it's going to be caught here and here. All right, and we got that 8 on there too. We talked a little bit, like briefly yesterday, about what happens when you have like a, multiplication of 8 or 2 or whatever, like a vertical stretch, that sort of thing. And it really doesn't do anything with these. They look a little bit tighter is all. So it's not a big deal. It's still got that same basic shape to it, and that's all I'm going for. So if you do happen to have a number up here other than 1, you really, as far as the graphing is concerned, you can just kind of ignore it. It doesn't make any difference really to the shape of it. Okay, so that's that one. This one's doing kind of the sort of the same thing, just a little different. We got an x plus 10 down there instead. So our vertical asymptote would actually be at negative 10. And then the same thing up at 1 for the horizontal. And it again had a reflection going on too, so it's going to be here and over here. All right, now that we got these graphs down, I want to transition to the next thing I wanted to talk about, and that's domain and range. So you guys tell me, what do you remember about domain of a function? That's how we would write them down, but what are they? It's all the x coordinates that work in the function. And likewise, the range is all the y values that can work in the function. So take a look at the graph. There's only one, at least for this first one here, there's only one x value that doesn't work. Negative 1. It's that asymptote, okay? That function never crosses that line, right? So it never has an x value of negative 1. So the domain we can write like this then. X not equal to negative 1. Okay? And what about the range? What's not equal to 1? Y. Yeah. Because range is talking y values, right? So, and with all rational functions, at least the ones you guys are going to look at, there's one vertical asymptote, there's one horizontal asymptote, and that's it. So you just got to find out where they are. X not equal to, y not equal to, got domain and range. Okay? So what's the domain of this one over here? X is not equal to negative 10. What's the range? Not equal to 1. Okay. So I'm going to give you guys just one last one to do. I want you to take it all the way. So do the division, rewrite it, graph it, domain and range, the whole schmack. If we can do that, we're all set. It's everything we got to be able to do here. All right, I'm going to switch things up just a little bit, but I think you can handle it. I'm going to make it 2x plus 1 on the top over x minus 3. Still follow the same process, and you'll be okay. All right, give you guys like maybe 2 more minutes to finish that up. And I'll show you what I got. All right, do we need more time or are we okay? If we're all right, take a look at it. All right. Come on, here we go. All right, so here's what I got. Take a look. Did my synthetic division, ended up with 7 as a remainder and 2 as my quotient there. So I went ahead and just flipped it around right away. So I got 7 over x minus 3 plus 2 then. Okay, or if you had 2 plus 7 over x minus 3, same thing. So it's going to be up 2 and to the right 3. So those are where your two asymptotes are. And then the graph should look something like that. There's no reflections going on in this one. There's no negative in front of the 7 or on the x or anything like that. And then domain, x not equal to 3. Range, y not equal to 2. So we okay with that whole process then? All right, then I'm going to let you guys just practice this stuff and see how we do. Like I said, I have a cold, so if you want to ask me a question, do so at your own risk. But I will attempt to help you. I'm going to just try and stay at my desk and grade some papers, so it's up to you. I will try to help assist you, though.